Good afternoon, Houston. My name is Joy Turner. I am the project manager for the PNNL Energy Science Center. Before we get started talking about our project, I'd like to introduce a few new hires. Welcome to Richland, Washington.
Hello, my name is Rigo Jimenez. This is my first project with Harvey. I come from the electrical background where I worked 12 years. That's where I started my safety.
Hi, my name is Andrew Givens. I am here on the PNNL ESC project. In 2018 of June, I started as an intern on the Anadarko Midland project. I graduated from Texas Tech in May of 20, and I drove to Washington State a week later.
Hi, my name is Justin Flowers. I joined Harvey in December 2019. I'm a Navy veteran with 10 years experience, and I'm a certified welder with 5 years experience.
So a little bit about our client. Our contract here is with Battelle Labs. Battelle manages and operates laboratories for the U.S. Department of Energy. This particular lab is at the PNNL, Pacific National Northwest Laboratory campus here in Richland. It's one of 17 national laboratories for the Department of Energy in the United States.
So the contract we have on the Energy Sciences Center is a design build, but a little different design build than you might have seen previously. I think most of our experience at Harvey has been what they call progressive design build, where you have a contract and a budget and you're developing scope, the owner's providing feedback, and at some point later we do a guaranteed maximum price, which is what we're very comfortable doing. But with PNNL, and what we've done with other clients as well, like GCGV, ME Global, so we've gotten fairly good at it, is we lump sum hard bid the job. So from the point that PNNL issued 900 pages of performance specifications outlining the methodology by which we're to design this project, we had to give them a hard bid, and from that we are then managing every detail of the design, every solution, every element to our very detailed budget. And PNNL as a client is verifying that we are at every stage compliant with their specifications. And they have about 20 engineers on their side making sure that we are compliant. So it's a little bit of a trick because 100% of the risk resides on our shoulders from the very moment we were awarded the job. So I think it makes it fun, I think it makes it interesting, but you have to really be on your toes because of the risk that we're taking on.
Now I'm here at PNNL, and PNNL has 3 other manuals besides ours. So altogether it's 4 manuals. We have our manual, and then we have OSHA's Washington's OSHA, which is called WISHA, and then we also have the PNNL Safety Manual, which is more of the Department of Energy, and the 1600 manual, which is more of the contractor responsibility manual. So they're all pretty specific. WISHA likes to think that theirs is more detailed, more specific. We also have what it's called cultural findings. If you find any spearheads, any arrowheads, different colored dirt, funny looking stones, do not take pictures, do not take them home, and do not post them on social media. We also have safety walk meetings on Thursdays with all the foremen. We do a walkthrough, checking out on everybody, making sure that everything's where it's supposed to be and the way it's supposed to be safety-wise. And we also have a safety walkthrough with the owners on Wednesdays, and we walk with them and they see if everything is up to their standards. And I'm proud to say that 99.9% of the time, everything has been correct. The other thing is migratory birds. If you have a bird out here and they create a nests and they lay eggs, we need to barricade the area. We need anything that was nearby cannot be touched. So if you have equipment, material, anything of that sort, you cannot come near it. PNNL comes once or twice to check on those birds, make sure nobody messes with them, and it's a $100,000 fine if you mess with those birds.
Out here at ESC, our project consists of 150,000 square foot. It also consists of a office area, lobby, and lab modules, which we have 52 lab modules. 6 of those lab modules are high performance labs. That includes a floating slab and very specific spec materials, including fiberglass rebar. Matt will tell you more about the purpose of those materials in the high performance labs. We also are standing next to a 2,000 square foot heat transfer building.
So this is the HTB. It's the heart of our heat transfer loop that runs the entire campus. During the summer, all of the buildings on the campus will reject heat to the loop. They'll come here, they reject it out through the cooling towers, and in the winter, the HTB will pool heat from the data centers on the campus and use it to preheat the hot water at each of the buildings.
Hey guys, Matt Gonzalez, Assistant Project Manager, standing in one of ESC's 52 lab modules. Each lab module has a combination of these worktop benches, fume hoods, some specialty fume hoods like for laminar flow or biosafety. And all these pieces of equipment are fed from ceiling service or wall service panels that house a number of utilities, anything from compressed air, vacuum, compressed nitrogen, compressed argon. They have chill water circulation loops for cooling lab equipment. And then also we have some specialty labs in this facility as well. They get compressed hydrogen. Some of them get liquid nitrogen for cooling large magnets for experiments. And an important thing to note also for these labs is that they're all built modular and they're meant to be renovated. The demising walls between each module are meant to be either torn down or built up to facilitate the owner taking full control and customizing their building later on. So now we're in the service corridor right outside of the lab module we were just in. Here's where they're going to store compressed gas cylinders for the specialty gases going into each lab, as well as chemicals and equipment for the experiments they're running inside. Directly above us is the interstitial space, which is essentially a mezzanine that runs in between all of the lab modules and feeds it with the utilities that I listed out earlier.
This is a typical intersection of the interstitial space. Every lab has supply air going to it. On each supply into the labs, there is a heating and cooling coil. There's the water for each of those coils. Process chilled water for each of the labs. And then we have the house gases and task exhaust and general exhaust for each of the lab. The task exhaust is all stainless steel welded duct, and the general exhaust is galvanized. And like I was saying earlier, we had to place each of the valves in the BIM model so we could show the owner, fly the owner through, show them where everything was going to be so they could see that was all accessible. Not only that, but we have to label each one of these, have a master spreadsheet with 2,500 valves on it that has the location, what it serves, its normal operating position, and the valve tag number. And now we have to go through and put the tag on each one of these valves.
So I'm now standing in the high performance instrument lab. The idea behind this lab is that it's meant to house extremely sensitive imaging microscopes and other pieces of equipment. The construction of it isn't too complicated, but there's a lot, so I'll try and break it down. Underneath our feet is a concrete slab isolated from the lab wing adjacent to us. It's anywhere from 1 foot to 3 foot thick. The idea there is to dampen vibrations coming up from the earth. On top of it is a structural steel structure, corrugated metal roof deck. Again, completely separate from the adjacent lab building, separated by seismic joints. Inside of that steel and concrete shell are 4 CMU lab cells. They're just freestanding large cubes on top of the slab on grid, and they're capped with a cast in place concrete lid. Each cube is lined on the outside with acoustically absorbent gyp, 6-inch walls, again, completely separated from the lab cell. And on the inside, at some point, we're going to put acoustic wall panels in here to absorb voices and vibrations and stuff like that. So now we're in the service corridor of the HBIL. I'm standing on a floating slab similar to what you put in a high-rise basketball court or a gym or something like that. Except the intent here is to isolate vibrations going into the high-performance instrument lab cells. Out here is going to be all sorts of pumps and chillers and things that will make noise, so that way it doesn't affect the experiments inside since it's on this floating slab. Also, eventually we'll have our electrical panels for the lab cells in here. They'll be shielded to mitigate electromagnetic interference to the microscopes in the labs. And lastly, all of our utility connections that go into the labs have flexible connections. That way, again, they don't transfer any vibration into the room. It's supposed to be completely silent. So now I'm inside of one of the high-performance instrument lab cells. Specifically, I'm standing on a vibration isolation table. It was specified by our vibration consultants that we have for this project. It essentially works on the same principle as noise-canceling headphones. The table senses incoming vibrations from the ground, the concrete slab underneath it, and then it outputs a vibration in a negative frequency to counteract the incoming vibrations. So with the culmination of this table that was also set by IQI, that did a fantastic job, the culmination of this table, all the belts and suspenders of all the other vibration mitigation that we have in this building and these thick concrete walls, the idea is that the Department of Energy will, when we turn this building over, be able to stand up a $10 million microscope the size of a Suburban right here and be able to look at objects all the way down to the atomic scale.
Hey, up on the roof, going to kind of go over the supply to each of the labs. Every lab has about 4 air changes an hour. We have 6 MAUs feeding fresh air to each of the labs. One of the MAUs will be in standby every day, and that rotates each day to a different unit. This is kind of the supply side, so now we're going to go to the exhaust side. All right, now we're looking at the exhaust side of the air systems for the labs. We have 4 400 horsepower fans up on the roof. Again, just like the MAUs, kind of redundant. One of them will be in standby every day. They'll cycle through the 4 units. The ductwork behind me is stainless steel. It was all fabbed in our mechanical contractor shop, flown up here and set in place. The redundancy in the fans and the makeup air units allows for increased reliability for the lab user, no interruption during the research.
Lastly, we're building a lobby and 40,000 square feet of office space.
Okay, one of the challenges that we had on our schedule out here is we signed a contract with the client for Monday through Thursday, 6 a.m. to 4:30 p.m. So if we wanted to work Fridays, we had to get permission from them a couple of days ahead of time. And if we want to work before 6 a.m. or after 4:30, we had to go get permission to make sure they were okay with us working that. They had to be here. They had 3 construction managers. They have a safety manager that has to be on site if we're here. So we're working every Friday now. I think we kind of wore them out, and so they agreed we're working every Friday. The tough thing about it when we first started was coming out of the ground, pouring concrete, doing the foundations. You really need that extra day, that Friday, just for pouring concrete. It helps out quite a bit. It's tough to do it on a 4-day week. So if we wanted to change due to heat, due to lighting, all the subs had to agree if we want to change our work hours. If we want to start at 5 due to heat, or if we want to start at 7 due to lighting outside, then all subs have to agree to it. If not, it's the 6 a.m. to 4:30. Holidays, if there's a holiday on the weekend, Monday was a legal holiday for guys out here, so the site's always shut down on a Monday if you have a holiday on the weekend, unless you pay them double time. Another challenge out here was just daylight hours, especially in the wintertime. It didn't get daylight until 7:30 to 4:15, 4:30. It would get dark. So 6 a.m. starts, that means we had to light the whole place up. We had like 6 light plants out here to light it up just so we could go to work. Fall and spring is probably normal times, and Summer, it's normal times. It gets daylight around 5 and dark around 9, so you have quite a few hours to work, but there's only a 10-hour slot in there to work. Labor out here was another unique thing. There's a strong union presence out here, which means all these guys have high wages, the craft workers, but they're trained really well. They do good quality workmanship, good production too. They're proud of what they do and how they do it. Even forming footing and stuff, those things are square to the half inch. Don't have to be, but they just have pride in that to make sure they do a good job out here.
We're 15 months into construction, and to date we have performed 1,005 inspections and tests. One special attribute for an inspection and test we performed on underground plumbing, to include process, sanitary, and sewer, was we utilized a piece of clear PVC on top of the pipe to alleviate any ladders being used for ladder safety. Created a window to actually see the water level and made it easier for our inspectors to verify that the head test was performing. On this project, it was one of the requirements by the owner to submit our quality control program, and since then we have been audited 3 times, and during those 3 times they have only found one finding, which was a calibration sticker on a slump cone. So I think we're doing pretty good on that aspect. The authority having jurisdiction, which is actually our client, we aren't required to have inspections by the local municipalities, but Battelle and PNNL actually perform our fire code inspections, electrical code inspections, structural, plumbing, and witnessing of all testing.